knock the door? Sure. On 3A there, you're writing a ratio, and writing that ratio is like what we did yesterday with the scale factor, okay? When you write that ratio, the order that it appears, that's how you're going to write that particular ratio. Now, on 3A and even on 3B, really it's going to be 3B what I'd like to really talk about is, and really I guess 3A is still a good one, either one, too. You got to watch out for, you got to be in the same units. So 3A and B kind of actually go hand in hand. It doesn't matter what unit you want to convert into. You just got to be in the same units. They will all reduce down to the same thing eventually. So as I see here, 11 inches, and the other one is 3 feet and 3 inches. Again, you want to convert one into the other and then write your ratio. So on my work that I had here, I changed everything over to inches. So 3 feet and 3 inches, I took the 3 feet. We all should know how to take 3 feet over. 3 feet going to our science classes. 1 foot makes up 12 inches, right? So those units are going to cross out. 36, right? 36 inches is 3 feet. But don't forget that itty bitty 3 inches we still have there. That's where I'm getting that 39 from. When you write a ratio, again, we need to be in these same units. And then the units are going to cancel out. A ratio then is just a number. It's just a comparison of two numbers then. And then the units cancel out. That's why I'm saying 11 to 39. Now on the other one, I went ahead and wrote it as in terms of feet. That 2 feet 6 inches for me was nice enough just to say 2.5 feet, because 6 inches is half a foot. So I just went ahead and said, hey, 2.5 feet. The other one was in already feet, and then I just let my calculator reduce that down for me. So I'm in the same units, feet and feet, and then go to your calculators, guys, and punch in 2.5 divided by 8. When I punch in 2.5 divided by 8, as this thing warms up for the day, all right, I should be coming out to be, what my answer says, 5 over 16. 2.5 divided by 8, math it out, the fraction, and that's where I'm getting at 5/16. If you would change it over to all inches, okay, like I did on the first one, I promise you it'll still come out to be 5/16. Okay? So be in the same units. That is what you got to be in. Okay. Good question on that. And the same thing happens on 4B. All right. 4B is I'm talking here. 4B, that is a TOPS miss every year, where students are not paying attention to those ratios, and they say longer side to shorter side, and they go 21 to 3, and that's it. They say, hey, it's just 7. All right. We're just starting over home, okay? 21 to 3, all right, and they say it reduces down to 7, but they're not paying attention to those units. Actually, the 3 feet is the longer side, isn't it? It actually is not 3 feet. We're going to change those over to 36 inches, and that's why I have that going there. Okay, so thank you, Nevaeh, for starting this off like that. That's good. 2 good ones for you to talk about. Okay, keep going. Other questions anybody's got? Chloe? Number 2. So back to where we were talking about yesterday, with either enlarging or reducing things. We're talking. We worked with yesterday with pinching in and out, with that zooming in and out. Whatever that scale factor is, here we're talking about that scale factor being a factor of 7. So if you're going to have a scale factor of 7, what does that mean is going to happen then? Is that going to enlarge or reduce? It's going to enlarge, right? So the way that we determine what those new coordinates are going to be is just going to be simply multiplying. We're just going to multiply those coordinates by that factor. So 7 times 3, 7 times 4. I don't say like, oh, that's that simple. It is that simple. It goes right back to when we did our translations. Remember when we did our translations and we said, do like x plus 4? And all we did was add 4 to the x. It's the same idea. The only difference is we're multiplying them. If we were taking 2/5, 2/5 is between 0 and 1. This is going to reduce it. This is a reduction because it's between 0 and 1. So we're going to reduce this down in size. but we're still multiplying. So I took -3 times 2/5. All right. When I take -3 times 2/5, that's where I got 6/5, -6/5 from. I took 2/5 times 5. 5 times 2/5, just going back to multiplying fractions, guys. 5 times 2/5, it reduces the size, it's getting closer. Reducing the size is really getting closer back to the origin. It takes me down to 2. You just multiply. That's all we're doing for multiplication there on dilations. Okay. Good questions there. Anything else anybody's got this week time to ask? Going once. Going twice. If there's nothing else that makes your name draw it, throw it in the basket. Let's get those books out. And let's pick up. Talking over here is Sam and Caden and Kara here. Sam had drawn out had drawn out an option. Unfortunately, he was still in yesterday's mode, but then we were talking and they started to get into an option that did start to work. They brought in the idea of using maybe some rectangles. What do we know about a rectangle? All 90-degree angles. Okay, so I got a rectangle going. And then with those rectangles, a rectangle is a rectangle, right? So all the angles are 90 degrees, right? Now, with the rectangles here, I meet the first part. All the corresponding angles are congruent, aren't they? But now I don't want to set it up to where all the sides are proportional, right? So, I mean, I could make something like this where it's 1 to 3 here, or 1 and 3 here. It's a 1 by 3. But over here on the other one, you know, this could be what? 2, and this could be a length of 5. Are those proportional then? They are not, are they? So it does match up with that where, you know, a square is always going to work, isn't it? And that's where I think Sam was at. A square is always going to be working as similar. Because all the sides are, all the angles are always going to be rights. And all the sides are always going to be the same because a square is a square. So a rectangle gets me that other option then. So what do we have for the next one then? Did we get to the next one? So let's go back to that square. Okay. What's a square that is not having right angles? Rhombus. So a square and a rhombus here is where the case I have, I want proportional sides. Okay. But what I could then end up doing then is taking out those right angles, creating myself a rhombus. And do I have proportional sides? I do. And I could even I don't have to make those the same. I could make those all 3, I should say. Those are still proportional. Okay, they're all proportional. But are the corresponding angles congruent? No. Okay. All right. So today, what we're looking at here is our shortcuts. Everybody likes a shortcut. All right. What do we do at the end or through the halfway of yesterday? We had to work through and we flip it back to page. Let's see what we flip, Chloe. We flip it back to page 453. Okay. On page 453, when we did our examples here, that's where we did all of our work to show what 2 things. All angles were congruent, and what? All sides were proportional. That was a bit of a lengthy process there. Today we're going to look at 3 shortcuts that cuts down our time just a little bit. We don't have to necessarily show all that information every time. And actually, most of the time, we're not going to have all that information out there. We're not going to have enough information to determine if all the angles are congruent and all the sides are proportional. So we're going to have 3 shortcuts to similarity today. So let's look at the 3 shortcuts and let's take those shortcuts. So what I pass out to you, take those scissors real quick with you and your buddy, and just cut those right down the horizontal. Separate those 2 examples out. We're going to use that first example here in just a second. Okay? So you and your buddy don't stab each other. Okay? Unless, I don't know, maybe I might be okay with somebody stabbing somebody.
Oh my god, I hate this.
All right. So we got three. Okay, so we got three shortcuts here today. And the first shortcut we're going to look at is on the next page. Now, on page 461, okay, we're going to use that top example. Like I told you guys yesterday in our book, a couple of the examples in the book just don't work out very nicely. So that's where we're going to use these two examples. We just cut it in half there. And we're going to use this first one right here. So let's grab that first one out, and we're going to put that on page 461 instead of what they have right there. Okay? So on page 461, well, we're going to talk about our first shortcut today. Our first shortcut today is called the angle-angle similarity. Okay? Angle-angle. So, AA similarity. Now, what we mean by AA similarity, let's take a look at this. So, let me bring that up for us. All right, you grab that. Oops, there we go. All right, I forgot to pass out to you. I should have passed out earlier. We're going to take our protractors, grab them out for us. What I want you to do is go through and take that example that's there, go through and measure out all 6 of those angles. Okay? Go through and measure out all 6 of those angles. Go through and measure out all 6 of those angles. We'll measure out all 6 of those angles there. It sounds like pretty much we're all getting the same measurements. They all should add up to roughly, not roughly, they should all add to what? 180.
Oh my goodness.
So walking around, it sounds like they are all adding up, or sorry, all getting right about 30, 50, and 100, right? So here's what we've got, okay? If we know at least 2 angles in one of the, in both of these triangles, 2 angles are congruent to 2 angles in another, which we have that. We were able to say angle 30 is congruent to angle 30. So angle R, find some room here. Angle R is congruent to what? Angle L. And angle S was congruent to what? Angle M. Then we're done. That is actually going to turn out to be enough information to say that we have similar triangles. We want shortcuts. Shortcuts are nice. We had no side information on it. That's a blank triangle on there. So that's going to be our first shortcut information here. If you have 2 angles congruent to 2 angles in another triangle, we talked about this yesterday, that the third one has to then turn out to be congruent as well. Okay? But if you know 2, we're done. That's going to be enough information to say that we have similar triangles. And the shortcut that we call it is what we call angle-angle similarity, or we shorten it to AA similarity. Make sure you use a little symbol at the end. If you don't at the end, later on here in a second we get something else, it means something else. So angle-angle similarity, let me go back to my part of notes. So angle-angle similarity is what we've got, okay? So on to the next page then. This is what we just kind of shown using our protractor, okay? That if 2 angles of one triangle are congruent to 2 angles of another, that is enough information to say that we have similar triangles. And then just like we did yesterday, we can write what we say is a similarity statement, all right? Triangle ABC is similar to triangle DEF. So on your little piece of paper there that we have, write me a similarity statement. Name the first triangle. I don't care how you name it. How are you going to name that second triangle then? Name me the first one. How are you going to name the second one then? Does it matter how you name them? No. The first one doesn't matter, but the second one is dependent on the first one. So what's the similarity statement here? Triangle what? RTS, there better be not no baby C. RTS is fine. But now that you've locked in RTS, R has to go with what? T, P, M. So when we say what's a similarity statement, you can only do that once you've shown they're similar. And why do we show they're similar? By angle, similarity. So yesterday we had to show all those things. We don't have to do that today. All right. Shortcuts is where we're at. You like shortcuts, let's learn to use them. All right, let's keep on here today. All right. Now, let's look at this one next here. All right. This bow tie picture. I've got one pair of angles. Where's my second pair of angles coming from? The middle. The which ones? Vertical angles. We've seen that bow tie picture quite a bit here. So don't forget about our vertical angles. So I've got, let's state it off to the side here. Angle A is congruent to what? Angle E. That's one pair of angles that was given to us. It was already marked up. We know the right angles congruent. Where is the other one coming from? Vertical angles. Now how are you going to name those two angles we just marked congruent? Name me that first one. Don't say angle C. It's got to be a little bit more than that. 3 points. Angle what? How are you gonna name it? ACB. And if you're going with ACB, what's it got to be on the other one? A goes with E, right? E, C, D. And then that's it. We're done. We now have enough to show that these are similar. Why? Because of a similarity. So triangle, name it out. Name me these two triangles and we would be done to show that these are similar. ABC is similar to triangle what? If I went with ABC, you're going to say what? EDC, I heard. And why? By a similarity. We're using our shortcuts today. We're finding our shortcuts and using them. I don't have to show everything there. Hell, I can't. I don't have any side information up there. Do you know anything about the sides up there at all? No, I can't do that. Now, let's throw out some side information on the next one. Okay? So let's flip it to the next page. And on the next page, I guess we're not there yet. Okay, on number 5, the top one. What type of triangles we got? Okay, A and B look pretty darn similar, but there is a difference here. Each triangle is isosceles. Yes. Determine whether you have enough information to show these are similar. These are similar. Do we have enough to show that these are similar? Let me give you a couple minutes here. A and B, yes or no, can we determine that these are similar based off of a similarity? Up here, we don't know that this is the case. This could be 30 and this could be 40. That's not enough info. So, watch the markings. All right, next one up. Let's turn it to next page. All right, like we did yesterday. Unfortunately, on the next one, we're back to all the sides. Let's say we have no side information, then I'm going to come around and take away all of your protractors. Okay? Go find me now. Match up those corresponding sides. That's not math related, so let's go. All right, on number 5 then. Small. What's the small side up there? On the left. 24. What's that correspond to?
16.
24 corresponds to 16, so VW, which is corresponding to YZ. and then reduce that down. Okay? What's 24 over 16 reduced down to? Or let your calculator do it, I don't care. Everything should turn out to be 3 to 2. All right, so everything's turning out 3 to 2. Medium, medium. What's your medium side? What's that? 33. Okay, and 33 goes to, I'm sorry? You said 22, right? Now, reduce that down. That one should reduce down by 11. That's a pretty obvious one. Which reduces down to 3 to 2. So far, so good. And what's our large? 36 to 24. Same deal. Reduce that down. Reduce that down by 12. That reduces down to 3/2. Okay? So, do all these sides turn out to be the same ratio?
Yes.
Are we then similar? Okay. We had no angle information. You cannot measure out your angles. So this is our second shortcut. Our second shortcut is what we call side, side, side similarity. So what we have here is, let's name it out. Name that first triangle however you want to name it. I don't care. How you can name that first one? How you can name that first one?
UVW.
Yeah, that's inappropriate. UVW. What goes with the other one? Mind your own business. What goes with the other one? To XYZ. Sorry, just go back to your. Let's put the desk back in order because you guys have seen it. So put the desk back in order. You really took me off today. So let's try this again. UVW with what? XYZ. And the reason why these two things are similar is by our new one, side, side, side similarity. Now, we have what we call a similarity ratio here, which is that 3 to 2 that we just found. So sometimes it's going to ask you, what is the similarity ratio? That's the scale factor we talked about yesterday. They call it the similarity ratio as well. You don't have to find anything else. You just found it. The similarity ratio is 3 to 2. So if they ask you what the similarity ratio is, you don't have to ask, you don't have to do anything more. You just have to state what you just found. You cannot state the similarity ratio until you've said, yes, they are similar by whatever shortcut you just used, which in this case was SSS similarity. So there's our second shortcut, SSS similarity. When you have no angle information, you got all side information. Okay. Let's get to our last shortcut really quick before our time expires. And on our time expires, we're going to use that other example I gave you right here on that next page, where that page is right here. We're going to put it right there, 466. Right there instead of that example, use that little half sheet that I gave you, that last example. And that's the one we're going to use. Okay? That one right there, the other bow tie picture. Now, what do we have on that one? Sides or angles? Sides, match them up. What goes with what? What side goes with what? Mm,
36 and 18 are total.
thank you. 36 is going to go with 18. So this is, imagine being rotated where YV, which is 12, is corresponding to over here VW, which is 24, which reduces down. Everything needs to be a half. 18 goes to 36. So ZV, which is what? Corresponding to VX, which is also what? 1/2 and 1/2. Now, I don't have a side-side. I have a side-side-side similarity we just did. But what we do have on that page that we're replacing this on is what we call side angle side similarity. The angle has to be between those two sides, and there's our vertical angles. It has to be between those two pairs of sides. So we're using our vertical angles here. What are those two angles? Angle what? Y VZ. And what's Y VZ congruent to? Y goes to what? I'm sorry? Yeah. Y corresponds to W, V, yeah, I didn't see where an M's at. W, V, X, I believe. Okay? So, what we have then is two sides and an angle. We have three shortcuts out there. We looked at the big one, AA similarity. Finish up the side similarity. And there's our third shortcut, which we call SAS similarity. So if we can match up with our last one here, SAS similarity, then we are similar. So name it out. Triangle what to similar to triangle what? I don't care how you name it. YVZ. YVZ is similar to triangle what? WVX by, and tell me what shortcut did you just use? We didn't use AA similarity. We didn't use SSS similarity. Caden said we use side angle side similarity. So today we're trying to figure out what three shortcuts we're aiming to use. Those are our three shortcuts. Now, one more time, if it asks you for the similarity ratio, it's nothing new to calculate. You've already calculated it. What did you calculate for the ratio? 1/2. Okay. So this is a 1-to-2 ratio. All right. So today is all about practicing those shortcuts, identifying them, and first seeing if they're working or not. Sometimes you're going to identify thinking, hey, it looks like it's SSS similarity, but in turn, all three pairs of sides